Hello, everyone. Hello, everyone. This is me, Totality High. Welcome back to another live stream of day 34 of 75 Ultra Hard Challenge, along with a recap of day 33 of the 75 Ultra Hard Challenge. Yes, I know. You might be thinking, why didn't I do live streaming? Of course, I was busy with the practical work, with the schoolwork. Our exams are starting soon, and I'm kind of busy based on that. I know this is my fault again. I shouldn't be doing these types of stuff, but we are not gonna give up. And I think the poll had already said and declared that I should be doing weekend streaming, so I decided to do it on Saturday. Now, for those people who may be thinking Friday is not supposed to be weekend, right? It is supposed to be a weekday. Well, I do agree with you, but in the Gulf region, it is said that I have to be doing live streaming on Friday because Friday is considered as a weekend in Middle East. That's why. So yeah, I have to do streaming on Sunday, Saturday, and Friday. But that doesn't mean that I won't be doing it right here. Also, I just wanted to mention a small thing about it. That is, you should not be giving up. You should move on. You should move forward, and man, I do know that it's a bit of a problem. And yeah, I forgot to turn on my camera. Let me do that. And we are gonna be preparing for a test. We'll be also doing some lectures, J lectures. Okay. Um, there is a problem. Actually, I did make a lot of backlogs, and I'm a bit pretty sad about it. But that doesn't mean that I'll have to give up. The main thing about this is that if we fall down, we have to rise back up. So that's one criteria here. We cannot keep falling again and again, or else we might actually like not even be in a position to wake up again. Um, let's start off. Okay, let me put my scene, and here we are. I think I will keep my camera a bit smaller because that's how it would be much better. Because I don't like showing my whole cam bigger. That's it. And we'll put a timer. My camera is not placed on a table, that's why you can actually see a bit of different perspective. But yes, here we go, this timer. Let's put 1 hour of completing theory and the reactions, and let's see if I can complete miracles too after like this 1 hour. After 1 hour, not now. So, strong electrolyte and weak electrolyte. I was studying electrochemistry for those who don't know. Let's not waste any single second. I'll try my best to actually not waste any. But yes, the thing is that my father will come here soon, so I have to change my place, shift it, and then we have to continue, which is going to be a pretty bit annoying, but I'll try my best not to actually waste a lot. So let's start. We are already doing it. Molar conductivity at infinite dilution or approximately zero concentration is known as limiting molar conductivity. What is molar conductivity? Molar conductivity is the conductivity of an electrolyte which is having an amount equal to 1 mole, and the electrolytes are of a unit area of cross section and of unit length. Yeah, that's it. Then talking about the variation of the concentration with the molar conductivity, or the concentration with the conductivity itself. We need to know that if the concentration is increasing, the conductivity is increasing. If the concentration decreases, the conductivity decreases. This is due to the reason of number of ions per unit volume, and there is a difference though. Molar conductivity varies. If you increase the dilution, actually molar conductivity increases. This is because of the factor of volume. If you look at the formula of molar conductivity, it is equal to the kappa, that is conductivity, into 1000 divided by molarity. Molarity has a factor of volume as its denominator, and denominator of volume. In this molarity, which is placed in the denominator, the volume goes up as a numerator, and this numerator acting as an increasing factor for the molar conductivity if we keep increasing the volume of solution. Now, the means of dilution is that if you increase, we are actually adding more solvent, which means overall we are just increasing the solution, right? That's why. So, what about strong electrolytes and weak electrolytes? Strong electrolytes are those types of electrolytes which can completely dissociate in its own aqueous solution. But about weak electrolytes, they partially dissociate, okay, and it can happen in its own aqueous solution, But the main thing about this is that we have to understand there are variations with the molar conductivity, and there is a graph which we can plot through it. If you look at the strong electrolyte, they actually go into a straight line, having a small point where this indicates about the molar conductivity of that particular strong electrolyte. But if you talk about the weak electrolytes, they have, upon like you doing their dilution, they actually rapidly increase. They show up a steep increase. They show a really strong increase. Actually, that's what we need to know. But if you try to increase the molar conductivity for a strong electrolyte, it doesn't affect much. It increases very slowly. Now let's talk about the uh, so, for strong electrolytes, increasing dilution helps the movement of ions present in it. A slight increase is observed with dilution, while when we extrapolate the graph into y-axis, limiting molar conductivity is obtained. My bad, limiting molar conductivity, not molar conductivity. Also, guys, I'm not teaching. Remember, this is the Feynman technique I'm using. That's why I'm saying this way. Let's start. Yeah, notifications. Okay, molar conductivity is equal to limiting molar conductivity minus a root c. Now, molar conductivity is the y, that is the y coordinate, and then y x coordinate is going to be the root c, right? Root c, and a is the no. Molar limiting molar conductivity is the sorry. Root c is the slope. My bad. No, a is the slope. Oh, what am I doing? A is slope, root c is x coordinate, y is molar conductivity, and limiting molar conductivity is yeah, y-intercept. Yeah, limiting molar conductivity is y-intercept. Okay. Limiting molar conductivity of weak electrolyte can't be obtained from a graph because a certain rise in ionization is observed when the weak electrolyte is diluted. The graph gets parallel to y-axis to get the limiting molar conductivity of weak electrolyte. We use Cole-Rausch's law. So we are finding the to find the limiting molar conductivity of weak electrolyte. We actually use Cole-Rausch's law. What does it say though? We cannot obtain it through the graph because the graph shows that there is a really large increase or a really big increase of the molar conductivity when we try to dilute it, which means that we're decreasing the concentration. And of course, there's a slight increase, which is helping the movement of ions present in it. That's what it says according to the reason. And then Cole-Rausch's law. We have to learn that Cole-Rausch's law. And I don't know. I'm not sure whether I'm pronouncing it correctly, but I think it's called as Cole-Rausch's law. Oh man, the pronunciation is going crazy. Ka, that is the dissociation constant of an acid, or Kb, dissociation constant of base, is equal to concentration into degree of dissociation squared by 1 minus degree of dissociation. That is C as concentration, degree of dissociation as alpha, so C alpha squared by 1 minus alpha. Alpha can be calculated by in terms of molar conductivity, that is alpha is equal to molar conductivity by limiting molar conductivity. Nice, we are cooking, guys, we're doing great. Okay, we have to do of course, the numericals too, but I think we'll first complete the theory part. Now we are coming up to the electrolytic cells and electrolysis. That is a bit basis of the idea of the electrolysis and the Faraday's laws based on this electrolysis thingy. Then after that, we are gonna study about batteries or cells, and yeah, okay, the product of electrolysis is also there. We'll check that out. Then we'll study batteries. That is prime. Oh no, over potential is also there. Okay, there are many things. Okay, got it. Then we got some reactions which we'll cook. Okay, don't worry, we can do this. So electrolysis has its own topic here, so we have to go through that. Electrolytic cells and electrolysis, which is fine. I can go through that. If you want, I can also watch a video based on this, and we'll give a shout out to that person who has created that video. So that's one thing. And then we're gonna check out other topics like overpotential and the products given by this through the reactions. Where we'll check out. And then we're gonna check out the cells. That is a primary cell or batteries, primary batteries, and secondary cell or secondary batteries. There are like Lange cell, that's dry cell, or that is dry cell is known as like Lange cell or mercury cell, or we got the secondary cells too, right? Yeah, secondary cell batteries are a bit complex. Nickel cadmium cell, fuel cells. Then we got the what do you call those cells? There are other ones, right? It's not here, right? They're supposed to be here. 1 minute. Yeah, it's here back. Yeah. Lead storage battery. This is one of the complex ones I've ever seen, actually, to be honest. Yo, stay hard, bro. Yo, Jofin, how are you doing? Thank you very much, man. I appreciate your comment. Thank you very much. I actually really appreciate it. Did you see my previous stream? I literally tried to stand by myself like for a long time, but that wasn't long enough. I have to try my best for the second attempt. If I get another chance, I will try to do it again. But let's see when, because I have to give more time right now for many of the work I have. Well, there was a huge problem. Like I wanted to do the drawings actually. So whenever I would try to do the drawings while I stand up, I was fumbling a lot of things up, and I had a technique of drawing. I was inspired by this one. So yes. Anyways, let's just continue. We cannot waste more single seconds, or you cannot waste seconds. Let's go. Uh, okay, we got an I know two twice, not that. Yeah, Farad's law. Okay, we need to go through this Farad's law. The limiting molar conductivity of an electrolyte is the sum of the contributors of its from its cations and anions. So the limiting molar conductivity of the electrolytes, of an electrolyte is the sum of the contributions, is the sum of the contributors from its cations and anions. So I'm not trying to do this, but okay. The limiting molar conductivity. So yeah, the limiting molar conductivity of an electrolyte is the sum of its contributors that from its cations to anions. Ah. Okay, so limiting molar conductivity of a chemical species, that is, like, let's say a salt, is equal to limiting molar conductivity of a cation plus limiting molar conductivity of an anion. Look at that up, and then electrolytic cells. Electrical energy is converted into chemical energy to help out during these non-spontaneous reactions. Anode is positively charged, cathode is negatively charged. Farad's laws, which are pretty much easier to do, so not a big problem. The amount of substance deposited or liberated at cathode, or amount of chemical energy produced, directly proportional to the quantity of electrical pass through electrolyte. Yeah, let's go. Faraday's second law of electrolysis. When even two or more cells are connected in a series, and the same quantity is passed through the electrolyte, the chemical change produced at the electrode is directly proportional to its chemical equivalent. I cannot do this, bro. What am I doing, huh? I'm not capable of this. I'm so stupid. I cannot do it. Okay, but products of electrolysis. It depends on nature of material electrolyzed. Okay, let's go. So Colrod's law. What's Colrod's law? The limiting molar conductivity of an electrolyte is the sum of its contributors from is the sum of its contributors from its cations to anions. Okay, no, it's from its cations to anions. Yeah. Okay, I'm going crazy. The limiting molar conductivity of a chemical species is equal to limiting molar conductivity of cations plus limiting molar conductivity of anions. Okay, electrolytic cells and electrolytic electrolytic cells and electrolytic. Oh my god, electrolysis and electrolytic cells. Uh, Chemical energy is actually released by the conversion of electrical energy into chemical energy, where it is used in the formation of not formation. It is used in the non-spontaneous reactions. Anode is positively charged, cathode is negatively charged. Various laws of electrolysis, first and second laws. So the first law says that the amount of substance deposited or liberated at cathode, or amount of chemical energy produced, is directly proportional to the quantity of an electricity passed through it. That is, weight of the mass of the uh, what do you call it? No, the amount of substance deposited, the mass of the substance deposited or liberated is equal to the charge, right? Uh, no, directly proportional. Okay, my bad. So we can say directly proportional to I into T into molar mass divided by high low. Okay, equivalent weight atomic mass by charge 65 by 2 into T by. Okay. Quick revision, quick revision. Let's go. Variation, strong electrolyte, strong is blind. Then we got the weak electrolyte, very because it's steep increase in the it's very strong increase in the dilution. And what else? Yeah, the slope formula. Molar conductivity is equal to limiting molar conductivity minus a root c. Limiting molar conductivity is the y-intercept. Y coordinate is the molar conductivity. X coordinate is the root c. A is the slope. Then we got the limiting molar conductivity weak electrolyte cannot be obtained from a graph because there is a huge amount of increase after upon dilution of a solution or the electrolyte. And then what else can we say of its aqueous solution? Yes, Kohlrausch's law. Oh my god, I'm gonna see up so much. Oh my god, the Kohlrausch's law. Yeah, we did that. Then yeah, the formula K is equal to C alpha squared by 1 minus alpha, where alpha is equal to molar conductivity divided by limiting molar conductivity. Uh, Cells and electrolysis, where the chemical energy is converted into electrical energy is converted into chemical energy, and chemical energy it's used in chemical energy is used in these non-spontaneous chemical reactions. And anode is positive, cathode is negative. Oxidation takes place in anode, reduction takes place in cathode. Yeah, that happens in electrochemical cells too, bro. Okay, Faraday's laws of electrolysis. First law is that the mass or the gas liberated from the cathode is directly proportional to the chemical energy produced is directly proportional to the electricity passed through the electrolyte. Weight is directly proportional to I into T, or weight is directly proportional to Q. Or Q is equal to NF. Mass deposited is equal to I into T into molar mass by NF. Weight equivalent weight. Wait a minute. We're saying NF is equal to Q. That's fine. Faraday's constant. That is big. That's big. Equivalent weight is also there, right? Equivalent weight. Atomic mass by charge. Oh, wait. Atomic mass by charge is equivalent to weight. Okay, got it. Mass deposited I into T into molar mass by NF. Faraday's second law: when even two or more cells are connected in a series, when same quantities pass through the electrolyte, the chemical energy produced at the electrode is directly proportional to the chemical equivalent. Oh, now I get it. They're using chemical equivalents. Yay! I have to use them. Okay. What else, bro? It depends on nature of material, electrolytes, and types of electrode potential species involved. Over potential, we have to learn that, and there's a phenomenon that we have to go through. Then the reactions. Oh yeah, reactions. How can I forget that? I'm so stupid. Yeah. Let's go. I'm so stupid, guys. Okay. Okay, bro. Go through the Faraday's law. The amount of substances deposited by an electrolyte at the cathode, or the amount of the substance whereof the gas is liberated at the cathode, or the chemical energy produced at the cathode. Oh my God, this is directly proportional to the quantity of It's not cathode though, right? The amount of chemical energy is directly proportional to the electricity passed through the electrolyte. Now Q is equal to ID, so W is directly proportional into I into T. Q is equal to NF, so W is equal to I into T into molar mass by Q by NF. Equivalent weight is equal to atomic mass or molar mass divided by number of moles of electrons. No, I'm stupid. Charge. Oh. Equivalent weight is equal to molar mass divided by charge. Yes, mass deposited is equal to I into T into molar mass divided by NF, where N is number of moles of electrons and Farad constant is equal to 98,500 or 98,485. Weight of zinc divided by equivalent. Oh, you have to go through that too, right? Yes, let's go through that. Uh, even two or more cells are connected in a series and when same quantities pass through the electrolyte, the chemical change produced at the electrode is directly proportional to the chemical equivalent. Let me just check. So, okay, we are going pretty solid. We are going fast, actually. I'm gonna be honest. MashaAllah. Alhamdulillah. Now we are already at the part of reactions almost, and then we are practicing reactions, and then yeah, batteries. These will take some time. So pretty much fast, very much fast, actually, I would say. Then we gotta go through these topics. Okay, first we'll go through the theory part of each and every part of it, and then we're gonna go through these reactions. That's what I'm gonna do. And then at the end, we're gonna practice numericals. Numericals will take some time. It's not easy, but we'll do it. Electrical energy is converted into chemical energy. Yeah, okay, that's done. Anode is positive, cathode is negative. Hey, let's go! Faraday's laws of electrolysis, the amount of substance is considered electrolytic. A cathode is the amount of chemical energy produced directly proportional to quantity of electricity passed through electrolyte. Oh my god, I'm being so annoying right now, right, guys? Let me just check how many viewers have watched me. Oh, 3 viewers as well. W. Faraday's second law of electrolysis. When even two or more cells are connected in a series, when same quantity of is passed through the electrolyte, the chemical chain produces the chemical protein directly proportional to its chemical equivalent. Okay, let's do that again. When even two or more cells are connected into a series, and when some quantity is passed, I'm gonna break my streak, bro. I'm actually a bit sad based on that. I cannot do anything about it. It's because of that silly day. I just wasted my time. I did not do it nicely. Could have done much better, but hey, man, I'm breaking my streak. I'm so sorry. You guys say no. What we can do, we cannot give up actually. The fact that I'm not even able to. I don't know what to do, guys. I'm so stuck. Please help me, guys. I don't know what I'm doing. Oh god. Yeah, that's what I gotta do now. This is the holy hard part. The hard way to learn. This is what I can do now. Like, the rest I can go through this to study those. Okay. You know what? Actually, 1 minute. It's important, but I don't want to waste my time. So what I'm gonna do, I'm gonna play this random one and mute it. Okay. It's my fault, bro. When even two or more cells are connected in a series and in same quantity. So see the amount of substance liberated or deposited, or the amount of chemical energy produced is directly proportional to the electricity passed through it. Yeah, that's easy actually. Now equivalent to it is equal to atomic mass by the charge. That's what I need to know. Then I need some charge of it, atomic mass by charge, and then yeah, charge of it. Then after that is Faraday's second law. When two or more cells are connected in a series, then the electricity passing through it is direct. No, when same quantity is passed through it, the same through the electrolytes, the chemical energy produced is um, the chemical exchange produced at the electrode is equal. It's directly proportional to its chemical equivalent, and then uh, this one line. Then we are moving forward. Come on, this formula, bro. Then products of electrolysis. What is it? It depends on nature of material, electrolyte used. Types of electrode. Okay, the electrode potential of species involved. Nature of material, electrolyte use. Nature of material, electrolytes, the nature of the electrodes, and then the electrical potential of species involved. Okay, over potential. Some electrochemical processes. What is going on? Okay, never mind. Over potential. Some electrochemical processes are processed. Uh, yes, okay, we got it. We need to understand this and that. Uh, okay. So yeah, our potential, some electrolyte chemical processes are slow at lower potential, hence extra potential is applied to increase its speed. Thus, it's called over potential. Some chemical electrochemical processes are slow at low potential, so extra potential is applied to increase its speed. Thus, it's called electro potential. Then what else you can say? Yeah, cathode. Okay. You're so close. So the when two or more cells are connected in series, then when some quantity is passed through the electrolyte, the chemical change produced at the electrode is directly proportional to the chemical equivalent. Man, I cannot do it. See nicely. Okay. When even two or more electrolyte cells are used. When two or more cells are connected in a series at same quantity of electricity uh, is passed through the electrolyte, the chemical energy produced at the electrode is directly proportional to its chemical equivalent. Weight of zinc is by equivalent weight of zinc is equal to weight of Cl is good, and weight of copper divided by equivalent of copper is equal to weight of Ag is equal to equivalent copper Fe. So there is a constant that is actually is equal for all these electrochemical cells. Yeah, that's what I can say. And then what? Two or more cells are connected in a series when same quantity is passed through the electrolyte. The chemical change produced to the electrolyte is directly proportional to the chemical equivalent. Oh yeah, yeah. I have to work more harder. Let's go. Yeah. Even two or more cells are connected. It's faster than the bullet chemical speed produced on the electrolyte is when two or more cells are connected in a series, then the electricity pass through, and when the same amount of electricity is passed through it, then the chemical change produced is directly proportional to its chemical equivalent. Mm. Oh, produced at the electrodes. Okay, I was so close. Somehow that somehow worked when I did this. When two of your series are connected in two more of cells are connected in series and same amount of electricity is passed through it, then the chemical change of the electrolyte is directly proportional to its chemical equivalent. Let's go, I did it. Okay, then same quantity of electricity. But still, hey, I did it somehow. Okay, that was weird. It depends on the nature of material electrolyte used. Depends on the nature of material electrolyte used, the nature of electrodes, or what else? Nature of electrodes, nature of electrolyte material used, and then the electrode potential involvement of the chemical species of involvement of the electrode potential of the chemical species. What is electrode potential? The tendency of the potential to be generated from high potential to lower is known as electrode potential. You stupid. You flip the pages. You flip the pages, you stupid boy. Don't know the electrode and the electrolyte. That's what I need. The tendency of the electron to lose electrons is used the oxidation potential. The tendency of the electrons to gain electrons is known as reduction potential. Okay, we're doing great. Depends on nature of. Okay, we can do this. Now we have the reactions, products of electrolysis. That's it. We can do this. We're conquering. Let's go. Then the primary and secondary. Then the corrosion, and then the prevention of corrosion. We can do this. Chemical kinetics. Never mind. Let's later deal with that later. Um, yeah, I'm not actually gonna be easily doing this. It will take some time, but I can do it. Depends on nature of material, electrolytes, types of electrodes, the electrode potential species involved. Some electrochemical processes are a little slower at lower temperature, hence extra potential is applied to increase its speed, thus called over potential. Na metal and Cl2 gas. I guess I have to go through that. That's how I can do it now. I'm heartbroken, guys. I don't know what to do. Products of electrolysis, aqueous NaCl gives. Some electrochemical processes are slow at lower potential, hence extra potential is applied to increase its speed. That's called over potential. Products of electrolysis of molten NaCl gives. To memorize these reactions. Okay, so we have all the reactions in most of these cases. Occurs only once and after over a period of time battery becomes dead. These are not rechargeable because chemical reactions are reversible. It is recharged by passing current through it in the opposite direction to be used. These are rechargeable because chemical reactions are reversible. Tri-cell, the Clanch's cell, use transistors and clocks. Um, okay, used in hearing aids and watches. Okay, nice. Anode zinc container which acts as anode. We have to learn the diagram. A carbon electrode, and then what's this? MnO2 and H4Cl and Zn2 plus ZnCl2 state. Paste. Cathode, anode. Some electrochemical uses lower potential or work at very low. Some electrochemicals undergo low reaction speed at low potential, so more potential is given to increase its speed. That is called as low potential. Products of electrolysis of molten NaCl. Na dissociates to form Na plus an electron, and Cl2 gives half Cl. No, Cl ion gains an electron to form half Cl2, and then what else? Products of electrolysis plus NaCl gives any again take no wait what why is there no any? Okay, so we are saying that Na plus, Na plus, and H plus ions are available. The reduction potential H plus is greater than Na plus. The H plus undergoes reduction to hydrogen cathode. Reaction at anode with lower value of E naught is preferred. H2 gets should get oxidized to preference. So oh my god, I was a bit scared based on that. Alright, scared me for a while. Uh, okay, we're kind of wasting time. You should know that. Okay, so you have this. So what happens is that H2 has more reduction potential than Na plus, so H2 undergoes reduction. But if you look at this, Cl2 and H2 should get oxidized in preference to Cl minus, and account of over potential of its formation of Cl2 is absent. Um, okay, okay, so reduction potential of chlorine is more, so H2 should undergo oxidation potential. Right, that's why. So again, NaCl gives H2, Na plus plus Cl minus, and yeah, that's true, right? So by this idea, we get to know that yeah, this works. Cathode here is forming this, anode is forming that, and this reaction looks something like this. So NaCl plus H2 gives Na plus plus OH minus plus half H2 plus half Cl2. That's interesting, huh? So Cl minus formed will be half Cl2 with one electron released, and then H2 reacts with no dissociates to HO2 plus 4H plus 4 plus 4 OH minus. And bro, what else do I need to know? Then yeah, H2O cathode. Okay, I have to practice this reactions, right? That's why. Then dilute H2SO4. Pretty easy, not hard, but takes time. Okay, one minute. Revise back. What else was there? We studied feasible. No, not that one. We should study about that. Yeah, solubility product, pH of the solution, feasibility of the reaction, calculates the, what else can we say? Yeah, the E cell, and then we can calculate the equilibrium constant. So there are many ways that you can use this for. And what are the uses for this? And this is for the uses of the electrochemical cell. But that doesn't mean what the main thing. But the main thing I want to know of this is that what are the differences? Electrochemical is spontaneous, is non-spontaneous. Electrochemical is capable of actually like having like the this is taking place in this different containers where the oxidation and reduction are different. But electrolytic cells have it on the same time. The electrical energy is converted into chemical energy, and for in the case of electrolytic cell, but for electrochemical cell, chemical energy is converted into electrical energy, which is interesting. And what else? What else? What else? What else? What else? What else? I gotta say? What else I gotta say, bro? Or else I'm really crooked. Not brand of crook. Electrochemical cells are of two types: primary and secondary cell. Primary cells are those which happen once in a lifetime reactions, which means that their chemical reactions are not reversible, they're irreversible, they're not rechargeable. Then secondary cells are those which are rechargeable, as their chemical reactions are reversible, and their electricity can be reversed back by passing current into the opposite direction to be used. That's what I can say. So yeah, and then dry cell, Lagrange cell, or let's say mercury cell. Those cells are primary cells. The secondary cells are lead storing batteries, lead storage batteries. Then nickel cadmium cells, fuel cells, right? Yes, we are cooking. Let's go, alhamdulillah. And then what else can we do? Yeah. So the products of the electrolyte itself. Okay, 20 minutes left. We can do this. You know what? Let's go through the corrosion. It is the oxidation of any metal in the presence of air, moisture, etc., results in the formation of compounds. Example: sulfides, carbonates, oxides, and sulfides. Then example: rusting of iron, tarnishing of silver, development of green coating in copper. Rusting of iron is an electrochemical phenomenon where oxidation takes place. So Fe is equal to Fe2 plus 2 electrons. Oxidation reacts with 4H plus 4 electrons. This is because forming 2H2O. That is at the cathode. So where H plus and electrons are avoidable, which will reduce it oxygen. The iron oxide formed further oxidized to convert it to this Fe2O3.xH2O called rust. 2Fe plus 2 plus 2H2O plus half H2 half O2 it gives Fe2O3 plus 4H plus. Interesting. So there is a reaction based on the rusting of iron, which we need to go through very well. It's a bit deep process, which is fine though. More reactive metal acts as the anode, which means that it should have very high oxidation potential. Combustible energy fuels to electrical energy. Interesting. Man, the reactions will take time. That's it. Then we'll do numericals. Numericals will be completed. It will take 2 to 3 hours to complete numericals, which is fine, not a big problem. But the main problem that I will be facing is how am I supposed to actually even do this, right? Like, there's another work which I might have to complete, and that's how I think I can complete the whole process. Okay, what am I doing? We have no time wasting. Dry cell, the plancher cell. Okay, let's start off with the product of electrolysis. Electrolysis. So any plus electron, Cl, just Cl minus half Cl to value. I'll try and get it. Come, Cl. So products of electrolysis equals NaCl gives H2 2H2O gives 4H plus 4H minus plus electrons. Yeah, it should be not 4OH minus. Now, water has more capability of oxidation, and Cl minus has more capability of reduction, because if you look at their uh, electrode potentials, we get to know that. And not only that, the over potential of the oxygen is one such reason that water would undergo most of the cases would undergo oxidation, and formation of Cl2 is observed. Now, NaCl on this reaction will form Na plus Cl minus. So what will be the overall reaction? So it will form NaCl in aqueous solution. It gives Na plus half Cl2 plus OH no plus 4H plus what electrons, right? Yeah, OH minus. My bad. Half H2. Why is half H2 formed? Oh, okay. H2O plus what? Okay, a bit confused here. Oh, we're dividing it. Bit confused. Not cell is equal to 0.00 volts. 2h2 is equal to O2 plus 4 plus for electrons. A not cell is equal to 1.23 volts. I'll do that. Roger that. Okay. A not cell is equal to 1.96 volts. A not cell is equal to 1.323 volts. This is 0, 0. Roger that. This is for the product of electrolysis of dilute HCl and not HCl, concentrated HCl. Okay. Okay, let's go. Erosion part, the reactions, and this one. Yeah, we can do this. Come on. I'll bring my practice book just in case we will run those all reactions. We'll copy this down so that we can go through this. Okay, we got the book. Let's start. We have many pens to work with, I guess. I hope I'm not going to get it wrong here. T minus uh, no, please. Huh? देखो Stop. Stop. हार्ट सब सबके ऊपर ही रहता है। वो प्लीज हटा दो वो हार्ट प्लीज अच्छा नहीं दिख रहा है। ड्राइंग अच्छा है बट मुझे थोड़ा डिस्टर्बिंग फीलिंग दिख रहा है। अच्छा नहीं हो Okay. I think there is something important that teacher said. 1 minute. Gotta check that out. You're progressing good, but again, I think we cannot complete the whole theory. Why is it always like this? What even is that? Okay, I didn't check that out now, actually. That's why. Window capture. Okay, never mind. You'll have to, yeah, we cannot complete it today on time, but don't worry, we'll not give up. Dilute H2 is a 4. Let me just take the battery out. Cathode, so H2O gains 1 electron, so it gets half H2 plus OH minus, and anode dissociates with this, so that is 4H plus plus 4OH minus plus, sorry, 4 electrons plus oxygen. Here E naught cell is 0.00 volts. E naught cell here is, okay. Okay, so wait a minute. Seal aqueous. dilute H2SO4 cathode. Oh no. Oh, wait a minute. I have told this on Saturdays. So yeah, there's something going on. Wait a minute. Why do you guys don't say anything, man? This is bit. I knew it. He's literally spectating. I don't know how he got to know that. Why do you guys know this? How do you guys know me, man? What? Okay, never mind. I was just checking. I'm just practicing reactions. I'm just, I'm just enjoying watching this. But I'm so sorry, guys. I was absent, by the way, so I had no idea about this. But it's fine. I can just go through this again and study all this because I have already studied this. Yeah, he said today. He said before he'll keep one later. And what about chapter one? Uh, man, that kind of surprised me. Okay. 2H2O plus 4H plus 4 electrons plus O2. Huh? Gas separated. E naught cell is equal to 1.23 volts. That's one thing. Concentrated though. Concentrated. Concentrated H2SO4, man. Cathode. H2O plus 1 electron is equal to. Uh, is there anyone watching my stream actually? Like, bro, what? What if they, like. Ah, yeah, there was one guy watching my stream. I see it. Okay. I knew it. So basically, I was just checking WhatsApp chats, and they're like, "Oh wait, there's a test tomorrow. I didn't know that." Guys, you should have predicted it, guys. I knew there is a high chance of it on being on Saturday. You should be prepared for it. I know. Maybe some people are busy with this and all, but trust me, bro. This is not safe at all. You have to try your best. Sunday is gonna be a bit dangerous because we have a lot of things going on tomorrow. We have biopractical exam, then we have chemistry test, we have physics test. Oh, that's a lot of fun. But let's see. Let's see. Uh, Anode. Huh?
I made a left hand secretary.
Okay.
How many are there watching? I did this with my left hand, by the way.
I can write reactions with my left hand, by the way.
Bro, this is a brain. You
Bro,
can
this is
can
my
you
left
draw
hand.
a brain with your left hand? No. So shut your mouth.
Yes, okay.
And I also did the shading. Bro, that is your left hand. I said right
Yes,
hand.
yes, left hand.
Right hand. You are a lefty. That's what you can do. Right hand. My heart, my brain. It's so nervy.
Nervy बराबर मैं मान भी नहीं पाया लेकिन कैसे पता
Shut up.
not tough.
Brain is hooked up to nerves.
That's not nerves.
I know.
It is made of neural. It is made of neural.
I know brain like brain से nerves ये होता so वो उसलिए attach नहीं रहता फिर भी वो
क्या 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 attach नहीं था
nerves
बराबर इसका
नहीं वैसा attached नहीं रहता nerves.
Okay, फिर क्या आता उस ब्रेन में
क्योंकि ऐसा डिजाइन के लिए ये करी
डिजाइन के लिए नहीं मालूम तुम्हें पूरा
No, you shut up.
You didn't study full biology nicely. That's why. I also didn't study biology in a really good level too, but still, I have learned it in depth too, right? We have a chapter based on neural control and coordination. I'm not boasting, I'm just telling you that we have studied it in a deeper way in 11th. I'm kind of wasting my time here, but let me just show. Brain with my right hand. Aro. The Lagrange cell. Now, primary batteries and cells. Um, 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 So wait a minute. so weird. What happened? Okay, never mind. Alright, zinc container which acts as anode, carbon dioxide was aluminum metal to see for carbon water. Only that anode to resistors and clocks, uh, hearing aids and watches, then secondary cells batteries, that is lead storage batteries, fuel cells, and then uh, fuel cells, lead storage batteries. There's another one. I don't remember. Cadmium cell. Then corrosion. We are so close in completing the chapter, bro. Super close. Today we'll complete full school level. In fact, okay, tomorrow we'll start off with the J level and NEET level lectures, so that we can complete that up, right? So 12-hour study, huh? Not 12-hour study, man. Up to 12 o'clock. This is gonna be fun. Electrochemical cells are of two types: primary cells and secondary cells. Ouch. Ouch. Again, ouch. Ouches, ouches, and ouches. Okay, so we have completed product of electrolysis, right? Yes, we did. Used in transistors and clocks. Anode, zinc container, carbon electrode, uh, with MnO2 and carbon, and then zinc Cl2 and NH4Cl are zinc Cl2 and NH4Cl are the electrolytes of this cell and dry cell. Yeah. Not only that, there is another thing that the cathode is. Okay, anode. Anode is what? Oh, okay. Cathode is this one. Zn Zn2 plus 2 electrons. MnO2. So you got batteries and cells. Batteries, cells. Okay. Uh, so do you have biopractical day? Oh no, Monday. Primary cell, dry cell, Lagrange cell. This is one thing. Batteries themselves. Yeah. I was just asking one of my friends. Okay, let's continue. So, cathode. Sorry, primary. I'm not gonna write down the definitions because it will take some time. Secondary. I'm just gonna write examples and start them off with each secondary. So, from my knowledge, what I know is that primary is when such answers are dry cell or Lagrange cell, or it is the mercury cell. My bad, mercury cell. Why do I forget these things, man? Even though I have them in my brain. Yeah, short-term memory, right? Yeah. Then we have nickel cadmium cell. Nickel cadmium cell. Then we got the fuel cells. Fuel cells. Then the lead storage battery, the most complex
Yeah.
one. हिबा क्या क्या ड्रॉ कर रही हूँ बहुत अनोइंग दिख रहा हूँ
तो क्या करो तुम्हें ड्रॉ कर सकती हूँ क्या
जा मम्मी अपने मुझे दिखा
नहीं दिखाती
स्पेशली अबू को दिखा पता चलता क्यों
क्यों
तो दिखाओ मालूम होता एग्जाम्पल डिस्टर्बिंग नहीं जी देखो पिक्चर्स ऑफ क्या ऐसे ऐसे तरह की पिक्चर्स इस्लाम में अच्छे नहीं होते बा वो स्केलेटन का स्पेशली हार्ट के ओके फाइन मान लिया ओके तुम्हें बनाई मैं तुम्हें रिस्ट्रिक्ट नहीं करूँ उससे बट वो स्केलेटन कुछ ज़्यादा गंदा दिख रहा हूँ नहीं मतलब ड्राइंग में नहीं इस्लाम में बहुत ये ना है पाओ समझो बात को तुम्हें किसी की स्पेशली तुम्हारे हाथ में एरेस करो सॉरी जाको अब्बू को दिखाओ तुम्हें पता चलता है क्यों क्या करता भी नहीं मैं बट तुम्हें समझ आता है खाली बोलो प्लीज Now let's start off with the dry cell, the conscious cell. मैं ऐसे नहीं बोल रहा हूँ मैं अप्रिशिएट नहीं कर रहा हूँ मैं अप्रिशिएट कर रहा हूँ बट इस्लाम के अगेंस्ट नहीं जाना है समझो बात को use transistors clocks some low types of low electricity using devices cathode and anode we have to understand that cathode is this carbon and electrode in the middle and the MnO2 coating around it. Coating, right? Is it coating? Surrounded by surrounding it. Yeah, that's it. Surrounding it. We don't know whether it's called as coating. I'm not sure about it. Um, then anode. Anode. We got zinc containing container, which acts as anode. Zinc container, which acts as anode. What are the paste used in the battery? ZnCl2, that is zinc chloride, and MnCl no is NH4Cl, ammonium chloride. used in the paste, used as a paste. You have to draw the diagram for this one, that's why. Anode, cathode, anode, it loses one electron, so it becomes positively charged, so no, two electrons, Zn2 plus two electrons. Cathode, though, cathode is a bit complex. What? Cathode, MnO2 plus NH4 plus one electron gives you NH3 plus MnOH, right? Okay, so drawing the Leclanche cell, you have this type of thingy, right? Then the electrode passing over it here, that is this much. Carbon, 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 carbon. Then cathode. Where is anode though? Anode, I'm a bit confused with that too. Okay, so this is Zn2 plus, right? Yeah. Um, NH4Cl as Zn2 plus. ZnCl2, sorry. This one Zn, that's it, yeah. Leclanche dry cell. We'll have to go through that again. So, again. Anode, cathode, Zn2 plus two electrons. MnO2 plus NH4Cl gives MnOOH plus NH3, and here it's actually NH4 plus one electron, my bad. Is it? Yeah. Then, yeah, that's how it is done. Then there is this mercury cell, Leclanche, try mercury cell. Mercury cell. Okay, so this one is actually not required as a drawing, but this is used for those low current devices like hearing aids, and there's another one called as, yeah, watches, of course, watches. My bad. So these mercury cells, they are interesting actually. These cells are somehow capable of, avoiding any kind of voltage fluctuations. You see, hearing aid can actually cause voltage fluctuations sometimes if you're using another type of devices or with the help of different type of primary batteries. And once that happens, it kind of causes an irritation with your ear. This is used for those people who are deaf and or have very less hearing aid, so they just hearing problems, so they just use this type of hearing aid so that they can actually hear it nicely and clearly. But if there is any voltage fluctuation, that can cause a lot of problems, right? So we need something which cannot cause any voltage fluctuations, so which means that we shouldn't have any kind of more ions to be produced or less ions to be produced, which means that there should be no involvement of a lot of involvement of ions in fact. So that's how we can actually generate electricity without actually forming ions, which is interesting, right? So yeah, that's how it is done here. So according to this, it says the anode is zinc container again, which means that again the same thing will happen to the zinc. It will oxidize. But what about cathode? Cathode will contain the mercury oxide, I guess, right? No, carbon. What is cathode? What? Um, no, no, no. This could be wrong. This is not. This is for the left launcher. My bad. Anode. So let me separate that up. Anode. Zn Hg. Okay, so this is how it looks like. Zinc mercury. Okay, what, 2 OH minus reacts to form Zn. What? ZnO plus H2O plus 2 electrons, which is a bit confusing. Okay. Then HgO plus H2O plus 2 electrons gives Hgi plus 2 electrons, which is pretty confusing again. And in fact, it gives 2 minus. Okay, that's fine. I get it. But why is there an iodine involved? So there is an involvement of iodine which we don't know about. So overall net reaction will be something like this, right? So OH minus gets cancelled. Okay, 2 electrons gets cancelled. So HgO plus Zn Hg gives ZnO plus Hgi. Interesting. That's actually pretty interesting, I'll be honest. Yeah, H2 also gets cut out. So what else gets cut out? H2O, OH minus, and electron. 2, 2. That's what I need to remember. So I think I found a technique. What do you mean by my obulus? Is that a bad word? I hope it's not. So I hope not. So let me just search that up. Someone like said, "What do you mean by that?" Okay, still don't get it. I hope that does not cause any problem. Meaning, yeah. Is it? Yep. Okay. Obulus meaning. Oops, not that. Wrong app. Yo, what's going on? Yeah. Why's my FPS dropping? Yo, what? Yo, what? My FPS dropping. Huh? Voice is translate to English. Yeah. Yo, what's going on? Is this in another language? A modern Greek unit of weight equal to 1/10 of a gram. What? Okay. See more. I don't know what's going on. I still have no idea what does that mean, bro. What do you mean by this word? I've never heard of it. It's mainly in German and Greek. What? This is not even in English, I guess. Okay. All right. Okay. So let me practice that again. So we got another idea, which is interesting actually. Net reaction. Now, so HgO plus Zn, no, Zn Hg plus HgO is equal to Hgi2 plus Zno. Interesting. So that's the net reaction, by the way. Yeah, that's the net reaction. Now, how do we use that for the cathode? And then for the, is there any electrode potential given? No. But yeah, anode Zn Hg plus H2O give, no, H2O give ZNO plus 2 electrons plus 2 OH minus? I'm getting confused. What is going on actually? I gotta remember. I have to just go through this. This is a really confusing reaction, I'm gonna be honest. Okay, net reaction may be easy to go through, but Zn Hg plus H2O, no, OH minus, that is in fact 2 moles, gives ZnO plus 2 electrons plus 2 H2O, no, H2O, that's it. I'm actually getting confused, I'm gonna be honest, 2 electrons. If that's the thing, then HgO plus H2O plus 2 electrons, okay, gives Hgi plus 2 OH minus. Okay, so we can predict the cathode reaction if we are looking at this. So in the Lagrange cell, the anode here, the zinc oxidizes, that is Zn forms Zn2 plus 2 electrons. But here in the cathode, it's Mn2 plus, that is MnO2 plus. That's like manganese oxide reacting with NH4 plus, that is ammonium ion plus 1 electron, that is giving us ammonia plus MnOH. I think that's manganese hydroxide. Could be, right? Is it? This mercury cell is very complex. It can actually like it has a confusing reaction. I'm gonna be honest. For the lead storage battery, the reaction is not given. It's given in words, which is pretty confusing, I would say. I think it would be useful for that, but if there is any reaction based on this, then we make it could. And yes, guess what? There is a reaction. Oh no, what is this? Oh no, what? Okay, there is a reaction. Well, why are the reactions getting more and more complex? Oh my god, bro. Ah, come on. Do it. Do it. Oh no, blood is leaking out of my leg now. I think I better not do that. Um, is there any tissue? Nope. Bro, why is this so time taking actually? I'm gonna be honest. This shouldn't be taking that long. We have one, two, three, 4 reactions to go. Oh god. That's time, right? Yeah, this will take time. I not expect that to be this long, bro. Let me be honest. How am I gonna do numericals then? Okay, so let launches, so I hope this does not take time. Again, let's go for primary. First one. Then we're gonna write there like overall net cathode Zn Zn2 no plus 2 electrons. This is anode, my bad. This is not cathode, anode. Cathode Mn2 oh MnO2 plus NH4 plus 1 electron plus gives NH3 MnOH. I don't know the net reaction. Oh man, the blood is leaking. Let me just wait. Didn't expect the blood to come out from here. Oh shoot. You don't know the bro. The problem is that I sit so badly, like on the floor. My legs can literally stare apart sometimes. I feel. Oh, matter नहीं पूरा भिला दे उठो 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 continue. Hey there, bro. How are you doing? सो जाएंगे। خلنا ننسى. Jadi aku may sarap to. Iba बुला रही है। खाली ये बच गया यार, थोड़ा डाउट है इसका। सही डाउट है। इसमें बताइए। 4 4s प्लस
चलो खाना खाए हिसाब खाना खाए एक बार खाना खा रही
मैं खाना खा रही नहीं।
बनाना अल्लाह का से मत कर दो खाना
Guys, I don't know why my FPS is dropping constantly. I think it's the WhatsApp that's open. Let me drop that out. Like, what is going on actually? Is there anything running multiple times? What? Okay, now it's fine, I would say. It's kind of good. It's kind of glitched. Let me switch off the timer. I know it was finished like 10 to 20 minutes earlier. I completed reactions, but not the numericals part. Now that's the tough thing. Oh man. Okay. Yeah, now it's fine. The FPS is fine now. Let's look at the live stream for a while. Let's take a glance and check this out. Um, Stop focusing, bro. Ouch. I said stop focusing. Yep. Now we are gonna use to check my video or my own live stream just to have a glimpse or a glimpse of what I'm actually capable of. Focusing. Yo, stay hard, bro. Nice. I look so weird in this. Why is my FPS dropping? Now we are gonna use. Why is my FPS dropping? What? Man, I should have sent him notes. I should have sent him notes. I can do it right now for him now. In fact, let me just do that. Mistake, I'm sending him late, but I'll try. I'm sending notes now. I know it's very late. It's my mistake. Okay, bro. Mm. Alright, so there are some things that I would like to usually say.
Sabar बेटे 12 घंटे भरी कब कब आ रही
12
हाँ
12
जल्दी आ जा बेटे सोने का है हाँ स्कूल जाना है रोटी कपड़ा मकान कमाने जाना है ओके तो ओके अल्लाह हाफिज जल्दी आ जा मैं सोने जा रहा हूँ
Are you guys still here? My bad. Focusing numericals just in case if anyone feels like why am I so quiet. I'm focusing on numericals, it's a bit soothing, it's a bit, comforting for me. I'll practice even more questions and then we'll go sleep, okay? Um, this is gonna be a bit time taking. So what do you guys say? Should I like end the stream and start this off because I really want to actually complete these questions and then after that I will do only some of them, not every one of them, because it will take a lot of time and I don't want to take that much. But yes, the questions will be done very quickly. I think I have to do, yeah. I'll go through the rest of them. That's what I'll do. For those which I have to go through, Faraday's first law, okay. I have it small out in second law of Faraday's. The numericals. I don't know how to exactly do that. Then I have to go through the Cole-Rouse law numericals because those are also quite pretty confusing, I would say. But the rest all numericals are fine. So overall, electrochemistry numericals are easy. I'm gonna be honest. They're a bit too direct. That's what I feel. So I like these numericals. They're fun, um, but it requires a lot of calculations because of the complex equations. But yeah, it's fine. It's only the nerds equation being complex, I would say. The other things are just fine. Plus, we have logbook. We can use logbook. So yeah, for that I'm happy. So Phil, for now, I know the stream is small. For hours is not the thing that you might be expecting, but I have been studying since the daytime, so don't think that I've been not doing that. Trust me, I have been trying to my best to like completing this chapter. We have overall completed physics chapter, studying it. Just have to revise it. Then maths notes. Yeah, the maths notes will be a bit risky. Chemistry numericals will be done now itself. I'll try my best. Then we will revise some reactions tomorrow with physics. Then biology. Biology will give some time. So tomorrow we will be doing completing lectures and all that stuff, so we can complete the balanced part of it. So for now, what are you gonna do? End the stream. I know backlogs are there. Don't worry. I'll have my own ways to complete it. Then for now, I'll end the stream. I will meet you guys later. And till then, see you next time. Thank you very much. Bye. Very weird outro, by the way.